Hi, today I'm going to talk to you about the final project, which is a Plants vs. Zombies type game. Um, and I want to build a small example that kind of shows you roughly the steps needed to start that game. So let's talk about the assignment a little bit first. Um, if you haven't played Plants vs. Zombies, I have a link in the assignment that shows you a place you can take a look at it. Essentially, in the classic Plants vs. Zombies game, there are you play a defender, and you get to pick from plants that cost some sort of resource, and you place them in a grid. In other words, you can't have two things in one spot. Then the zombies appear on the right side of the screen and move across, typically staying in their row. And when they hit a plant, they battle each other, and if the zombies get to your doorstep, then you lose. And if you wipe out all the zombies, you win. Each plant and zombie has slightly different behaviors, and that's what makes it a little more interesting and strategic. You have to think about where to place things. We won't be making anything quite as complicated as this, but it'll have all the major elements. So hopefully some of you have some fond memories of playing this game at some point in your life. And it is, I think, a good example of seeing how, especially using some classes you can inherit from, it's easy to build up sort of an interesting project in not that much time. Let's see. You need some kind of theme that's not just plants and zombies, or is not plants and zombies, but basically there should be a stationary kind of thing, a plant-like thing, and an attacking kind of thing, a zombie kind of thing. You're going to use a provided zombie and plant class and subclass them to provide some new behavior. And basically that behavior has to be somewhat creative, not just like this is a strong zombie with a big attack, or this is a strong plant with a big defense, because those are just numbers, right? You need something that has some code aspect. You're going to have random zombies appear in a random row. So I think in the real game they have sort of preset defined, they plan out how these things show up. And instead you're just going to have random zombies appear, but with some effort to make it so it's not just like either impossibly hard or too easy, some way of making it interesting to play. You're going to have at least two plant types, and so you need to have buttons for those. And when you click on a plant button, you're going to see if there's enough like gold resource, and then you're going to click on the field to place the plant, and it has to align to a grid and only place if empty. So in other words, again, if I were to click like here, it would just place it centered in that grid square. If I were to click here, it would place it centered in this grid square. And if I were to click here, it would not allow me to place it because there's already something in there. Now, I would like you to note that the lab from this week placed sprites, plants essentially, in a grid, aligned to where they are. And so you should be building on the lab to get that aspect of it done. And then today I'm going to show you how to place a zombie, have it march across the screen and attack one of the plants. Okay? And so you should build on that. So I think there's some reasonable structure here provided, and you should pay attention to that structure as you dive into your own game and not just try to reinvent it all yourself. Okay, so there are two phases to this assignment. You're going to get started this week and basically go up to Thanksgiving. And you need to get checked off at some point to get a little feedback on your first phase. Basically, we want to ensure that you're making some progress over this week, over this 2-week project. And so you basically just have to, I'll talk to you about how to do that, but find a little bit of time, 5 minutes, to demo it to a TA. And then the second part, after Thanksgiving, going up until the end of classes in a little more time. This is a partner optional project, and again, I'll have some details on that, but basically you are allowed to have a partner. That doesn't mean that one of you collects images from the web and one of you does all the programming. You all have to be involved in the programming. You must work together at the same time on the project. So that's the downside of having a partner, is that you have to find time to work on it together. And my suggestion is, if you're not in a position where you want to do this in person, in other words, you don't have some connection to this person already, you should do a Zoom screen share and switch who has control every half hour or so. In other words, one person should not be responsible for typing all the code. To facilitate that, there's different mechanisms. I mean, there's actually some interesting Eclipse plugins to allow like two people to type at the same time in a file. I'm a little worried about springing some new technology like that on you. My suggestion is to use a shared cloud drive like Google Drive or the University of Utah's Box, and you set the Eclipse workspace to a folder on that drive, and then as you type and save, it will sync up, and then when you switch, the other person has the project synced up and can just open the project and get started again. We'll have to, if there's any issues like with that approach, we can certainly talk about it like on Piazza or something like that. Okay, so let's look at the code. The code basically is building on what we did in the lab. There is a sprite that basically holds an image or a series of images. So if you want to get fancy, you can, find some set of images for, I'm not saying you should really be drawing all this stuff yourself. You're welcome to try to draw some stuff if you want, but really your best bet is to try to find some stuff on the web and grab those files and use them in your project. Sometimes you'll find sprite sheets that have a series of, animated 2D kind of pictures, and you can use the sprite class to manage that kind of thing. But if it's a single stationary image, just moving across the screen, that's fine too. It has a position, it knows how to draw itself. It has some collision code that you used in the lab, with the hitbox and so on, and colliding. And so this is sort of like the basic start to all the classes. Then we have an actor that inherits from Sprite, and again, you use this in the lab. So again, this extends Sprite, it inherits from Sprite, and it also implements this attack interface, which to be honest is not much. It is more of just to kind of show you, how you might do that. Attack basically says that it has an attack method. So any actor has to implement this attack method. But what an actor is something that has health. So in other words, it can die if it runs out of health. It also has a speed. So if it's something that does move, it can move faster or slower. And it has this cooldown counter, which is maybe something you think about a little bit, but basically it's a way of making it so that if you're a zombie, you don't get attacked every frame, 30 frames a second, right? Maybe you want to attack once every 2 seconds. And so this counter is basically something that says, I can't do my special behavior until this thing reaches 0. So it starts off at like 60 or something like that. Every time through the game, we update that and it goes down by 1. And then when we try to do an attack, we query it and say, are you ready to do your attack? So here's the update. It basically decrements the cooldown. Is ready for action basically says, is the cooldown counter less than 0? And if it is, that we return true. In other words, we're ready for action, otherwise return false. And then if we do the action, we can reset the cooldown back to its original value, so it starts over again. Same kind of thing, there's a health, and then it asks, are you alive, which means your health is greater than 0. Pretty simple. And then there's a health bar that draws a little, the health bar goes down as you get attacked. This remove action is basically something, I don't do anything with it, but basically you can imagine a zombie that when it dies, it has some special behavior. And you can add that into this remove action here. And the attack basically makes sure it's not attacking itself. And also that it's colliding with the other actor. And if it is, and it's ready for action, it does its attack and then resets that cooldown. So a lot of stuff's sort of handled for you already. Then there's 2 subclasses of actor. There's plant, which is stationary, and it only attacks zombies. So it overrides the attack method. and it says if this other thing that it's attacking is an instance of zombie, then go ahead and use the attack from what we inherit from actor. So in other words, the plant decides whether it's the special case that it's attacking a zombie, make sure that, and if it is, it uses that actor attack, which is here, and does like a standard attack, right? So plant's defense are basically an attack. Now a zombie, which I don't seem to have up. A zombie has a move, and if it's not colliding with something, in other words, a zombie moves along, and if it collides with a plant, then it stops. And so as long as the zombie is not colliding with something, it changes, it shifts its position by its speed. And basically, we set the collision status by checking if it's overlapping and it's a plant. So that, that's the state there. And we have to reset that is colliding every time to false so that it doesn't get stuck somewhere. Basically, as soon as that other thing goes away, you've killed the plant or something, that gets set back to false. And then its attack basically checks if it's a plant, and then it attacks the plant if that's true. All right, so there's a lot of different parts to this, and again, when you program, you're typically not starting with a blank screen. You are starting in some set of code, and your job is first to understand sort of the logic behind the code, and then figure out how you can adapt it to add the functionality that you're interested in. And again, we saw that we did that in the lab to start, and we'll do a little bit today here, and hopefully you can build on that and start to feel comfortable. But it takes a little while to feel comfortable. It's not like you can't just Google Java, what does attack do? Because that's our own code, right? We're creating our own ecosystem here, and you have to kind of learn how to fit into it. Okay, so the basic idea in the main program is that we're going to have a single array list of actors, and from polymorphism, that means we can put a plant object or a zombie object into that array list of actors, right? So this actor reference can reference a subclass. And then when you ask them to draw themselves, the plant draws it in a plant way, and the zombie draws it in a zombie way, because it uses the actual method for that subclass, not the general one for the actor, right? So that's the polymorphic idea. You can put subclass things in the superclass references, but then when you apply methods to it, it actually goes ahead and uses the correct one for that subclass. Now, the basic structure of this kind of project, of a game, there's this idea of a game loop. And a game loop is basically an infinite loop. And in there, you basically update stuff. So you go and tell all the different things in the game to, build up resources, work on that cooldown counter, update their health if they get healthier, check for interactions, they attack each other, they move, they all draw themselves. Now, if we just had a while true loop somewhere, then the user interface would freeze. In other words, it'd be stuck in that while loop and it would never go out and check for button presses and things like that. So the way we make an infinite loop in a game loop is that we use a timer and say, keep calling the action listener every 30 milliseconds or something like that. And that means it does one loop and then goes and checks for user interface events, and then the timer goes and does another loop and so on. And the only thing that makes it stop is that the game is over, or you close the window or something like that. So let's build a small example. In the lab, we had random plants popping up, and we could click on them to make them get damaged, and then they would go away when their health went to 0. In this case, I want to pop up a plant and pop up a zombie, tell the zombie to move across the screen. When they touch each other, they should attack each other, and whoever wins stays around, and whoever loses gets removed from the scene. So let's look at an example here. In this example, we're extending a J panel, and it's going to be embedded in a larger J frame. In this case, by making a JPanel, maybe we could have two games going on at the same time in the same window, in the same frame or something. Not that I really want to do that. And so we're going to keep track of, basically the main thing in here is this list of actors, right? So a game has a bunch of things that in it, plants and zombies, and they all live in this list. Looking at this now, I'm like, I kind of think these don't get used outside the constructor. Maybe they shouldn't be instance variables. I have to go remind myself why they're there, maybe out of laziness. Okay, so here's the constructor for this example, which is again a start of a Plants vs. Zombies. We call the constructor for the JPanel, and then we say how big we want it to be. So that's, there's basically just one big panel here. Now you're going to add some buttons and things, and so you need to think about how to add more panels and stuff to this whole thing. We're going to read in a file. We make a new plant at a certain position, and again, you would be doing it by saying someone wants to build a plant and then clicking on the screen and turning that XY into a row column and then placing the plant there. And we'll talk more about that. The zombies would normally appear randomly. I make it appear in a set place just because we want it to touch the plant when it moves. And then there's a bunch of very random looking numbers. These should be turned into static final constants. So they're named, starting health, starting, whatever it is. And so part of your job might be to figure out what all these different parameters are and turn them into something that someone else can understand. So we make up our array list of actors, and we add the plant and zombies to that same list. So they all live together in the same list. And to be honest, I debated a long time about having a list of plants and a list of zombies. And it simplifies some things, but then a lot of other code goes twice. I don't know. To be honest, I still go back and forth which one is the better way to do it. But this seems kind of fun to have a very high-level superclass as your array list and then add these things to it. And then I have a timer, and I say every 20 milliseconds, so 50 times a second, update the scene. Okay, so what does that mean? Well, what does update the scene mean? Well, that means call some action performed event. So this is basically the game loop, or one time through the game loop. And in here, we want to update all the different plants and zombies and make them do their thing. So what are the things we need to do in here? Well, let's start by moving the actors. Okay, so I'm going to have a for actor. So this is a for each loop out of the actors. Okay, so I'm going to grab one actor at a time, and I'm just going to, I'm going to say actor dot move. That's all there is to it. So if it's a plant, it doesn't move. The move method doesn't do anything. And if it is a zombie, it moves according to its speed. I think let's see, nothing will really happen here, I think. Okay, so we're not, we're not really moving. Why is that? Let's put a print in here and see if we're moving or not, or if we think we should be moving. So down here we can see, that thing's being called repeatedly. For some reason, it doesn't seem like we're getting the move that we want. Now here's the thing. How do we see these changed actors, these changed sprites? Right now, we see them by overriding the paint component. In other words, kind of like we did 2 labs ago. Or as I did in, maybe that wasn't the lab, as I did to make the flip book, right? We had to override the paint component. And in here, I'm going over the loop over all the actors, and I'm drawing them, and I'm drawing their health bar. So this should be showing the updated zombies. Notice, look, somehow when I resize the window, it is calling paint component, and we do see that it's moving. So the flaw here in the action performed is that we are moving the internal position, the state of the zombie, but we aren't drawing it on the screen. So we need to call that repaint at the end of everything to say update the scene. Okay, now it's moving, and I don't need my moved anymore. All right, so again, it's easy to get confused, but you have to first confirm you think, like, is this loop being called at all? Maybe at some point it'd be good to print out the zombie position and say, hey, its X value is actually changing and I'm not seeing it. And then that maybe guides you to thinking about why you're not seeing it, and the reason is that you're not updating the scene, okay? So this debugging process, of course, is always the key to making things work. Now, I'm not supposed to move when I hit the plant, and for that I need to update the collision status. So almost all the steps here involve some sort of loop over the actors, and in this case I need to compare the first actor against all the other actors to see if I'm colliding with them, and then the second actor and compare it to all the other actors to see if I'm colliding with them, as long as it's not itself, it's not another zombie, and so on. So I'm going to loop over actor again, call this one other actors, and I just need to set for the actor, set collision status of based on other. What this does is it sees if they're overlapping, and if they're overlapping, then, and it's a plant, then it decides to set that little value inside the object saying I am colliding with something. I got some kind of road construction going on outside. I don't know if you can hear it, but they're drilling in the concrete all of a sudden. Sorry about that, not much I can do about it. So I might comment this, move, check if overlap between zombie and plant. And again, this helps me when I'm scanning the code, just kind of figure out, which part I should be interested in. Okay, so let's see if this does anything. Okay, so now it's stopped, right? So what should they do when they, how am I gonna make them not get stuck forever? Well, I need them to attack each other. So I'm going to attack, and I'm going to say there's a distinction between checking for the overlap between zombie and plant, which is done for the purposes of deciding whether you're moving or not, and then the attack is also going to be checking for overlap. And the reason you have to do that is because if you attack it and you kill it, destroy it, then it goes away, and then you should start moving again. So we need to check for the overlap after all that happens. Okay, so so how do we attack? Well, I have to take one actor and check against all the other ones and see if I'm able to attack it, and then go to the next one and check all the other ones and see if I'm able to attack it, and so on. So again, there's like this double loop again here for the attack part. So I'm going to copy that stuff. So sometimes we have a single loop where we just say, hey, everything in our list of actors do something. Other stuff we have to compare every actor against every other actor, in which case it's this nested kind of loop here, right? So you'd be doing both those pretty often. And I'm just checking if the actor I'm looking at can attack the other actor, right? And again, that code already checks to see if it's the same one. So when this one loops through and this one loops through and they're the same, they won't attack each other. And this also handles then the case that it's not like a zombie cannot attack a zombie, at least the way it's set up now. All right, so I attack. Nothing seemed to happen. So why is that? Well, there's that whole cooldown counter thing. And so unless that starts getting decreased, where the first time the cooldown's at 30, then it goes to 29, then 28, then 27. We have to tell those actors to update their cooldowns. So here I'm going to say actor update. And again, that's pretty basic right now. It just changes that cooldown value. You could do more stuff in there. I don't know what, depending on how creative you want to get. Update cooldown. Okay. So this one's going in big jumps, which means this one has a long cooldown but a big attack. This one's kind of going down continuously, which means the plant has a small cooldown but small attack. And here they keep attacking each other because their health is negative right now. So we need to somehow remove, as soon as their health goes to 0, we need to remove it. All right, that's the next phase here. So attack, and then remove, destroyed. I'm going to say destroyed instead of killed. Killed sounds a little too violent. So how are we going to do this? So we need to pull out of this actors list those things that are destroyed. And as we did in the lab, there's an issue. You can't just start removing things from the middle of something you're looping over. That's this code modification exception you might get if you run your code and do that. So the way we did in lab was we built up a new list of all the ones that are still alive and just didn't do anything for the ones that were dead, and so they just sort of went away. And then we swapped in this new list for the old list. So we need to make an array list of actor, next turn actors. In other words, these are the ones that are going to be around next turn. And that's in a new array list that is empty. And then I'm going to loop over the actors. And notice here I'm, oops, oh boy. I am perfectly okay using that same, this loop variable only has scope in the for statement. And I can keep reusing it over and over again. And I think it's a perfectly good name to have an actor come out of a group of actors here. And we're going to ask if the actor is alive. If actor is alive, then add it to the next turn actors. We're going to add actor. If it's not alive, we don't have to do anything, but there is a behavior. There's this remove action, which is right now is not anything at all. And we're going to tell the actor to apply this remove action. We actually pass in actors to here because maybe you're going to end up doing something to its neighbors or something like that. You don't have to do anything here, right? But I'm trying to provide some structure, some hooks, that if you want to try to do something, you can do it. And so, for example, when if a plant were to be killed by a zombie, the plant, during its remove action, could decide to do something back to the zombie as a last gasp thing. And that's what this provides here. So after all this goes through, this next turn actor should hold all the actors that were currently alive after all the attacks happened. And we need to set actors to this next turn actors. Right? So we build up the new list and then we say, now let's work on this thing here. This is why we have to then check for the overlap again, because some of them have been removed. And so they might have been overlapping before the attacks, and now they're no longer overlapping. We want to move them. Okay, so we go. There's a battle to the death, to their destruction. Who will win? The hard-hitting Chihuahua or the quick-hitting frog? And as soon as it's gone, it continues on. And, well, we don't have any checks for the game over, but that would be, I would lose because I didn't place more plants or anything like that. Um, okay, so notice, hopefully, there's a lot of code here in this action perform. It's getting a little ugly. But to be honest, most of the code is really loop structures, right? Um, we loop over things and update them. We loop over things and compare them to all the other things and attack them. We remove destroyed actors, and we check to see if there's some overlap between plant and zombies, in which case they stop moving and then move. Yeah, I don't know. This somehow seems like a weird two-step process. It seems like it could all be done together here or something. It's not. I'm not totally happy with it. Your game loop will basically just look like this, and your job in the assignment is to add some more user interface, figure out how to get those plants placed, and add some special behaviors so the zombies are not just super boring and the plants aren't super boring. But that's really it. Um, so the hard part is figuring out where you make these changes in a way that you're not just destroying the existing logic and structure of these classes. And you also have to think about how can I live within this system. In other words, if you override a method, what do you have to work with? Do you know everything there is to know about everything in the game, or do you only know about some small part, like the list of actors or something like that? And so your creativity is bound by the structure, but of course that's where creativity comes from, right? Working within some set of restrictions. Okay, so this will all be posted, and look for the assignment phases coming up soon. Thanks.